Hi there, I'm Max Doolin. I am the founder of the Spokane Cyber Cup, and here we're going to go through a challenge. In particular, we're going to go through the bad keygen challenge. We're going to start by going to the challenge file. This is hacking cryptocurrency wallets. A cryptocurrency wallet is simply math. It's a elliptic curve digital signature algorithm key pair. If you know the key, then you own the wallet and all the crypto in it. Recently, it's been discovered that some wallet generation services have been hacked. What could have happened? To solve this, you need to find the private key with this specific address. The public key is so with a asymmetric cryptography, there's a public and a private key, and the public key is what you would give out to other people. However, to identify people in cryptocurrency land, we use what's called an address, which I think is just a hash of the public key or something like that. So it has been in the tweet that I linked there. There has been a lot of things that have been happening with cryptocurrency wallets. And the main thing is that people are generating the numbers insecurely. If I generate a wallet or the keys incorrectly, then somebody can actually predict it. If we go to the generate wallet here, we have a function which we'll come back to in a minute, and we have the seed. This seed is in the range of 0 to the 20th, which is a little over a million. Then we have generate key, which will actually get the key for us. So if we call generate key and we pass in our seed, it will then take in our random number and create a key from that. Now, there doesn't seem to be anything wrong here, but when you have unlimited computing power, 2 to the 20th is actually a really small number. Only a million possibilities. You can brute force that on your computer pretty quickly. So the problem is exactly that. If we know the seed, then we can generate the random number. And the way that we know if the random number we generate is the correct one for the given private key is based upon the address. So here it actually prints out the address for us. In order to solve this, we can pretty much use the exact same code. Instead of just generating, though, with a random number, we're going to do it in a for loop. So if we do this in a for loop and it goes to the 20, we can do this over and over and over again until we realize this key that we made, its address, corresponds to the address that was in our prompt. So write a for loop to iterate over all of the possible random numbers. Keep trying them until we find the one that has the right private key. At that point, it will output the private key for us. And in the other tab, I actually ran this. And we'll see here that the random number is about halfway into it. And if we cat the solution, this is, you can see L46 and L46. So the main takeaway is this is using bad random numbers. Don't do that.